Okay, so on Tuesday we talked about square roots and particularly what is rational square root and what is irrational square root. So today we are going to talk about irrational square roots. In particular, we're going to want to simplify these. So you know that if you have something like the square root of 25, that is 5, because 5 times 5 is 25. So 25 is a perfect square. If I give you the square root of 121, you know that's 11. Again, because 121 is a perfect square. Same thing if I were to give you the square root of x to the fourth. X to the fourth is a perfect square. X squared times x squared is x to the fourth. So today, we're going to talk about simplifying irrational square roots and what exactly that means. Now to do this, the first thing I'm going to have you do is create a quick list like this. And go all the way from 1 to, let's say, 15. 9, and then there would be 10, 11, 12, 13, 14, and 15. And then for good measure, let's do 20 and 25. Okay? Now what we're going to do with these is in another column right next to this, we're going to square each of these numbers. 1 squared is 1, 2 squared is 4, and then 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 20 squared is 400, and 25 squared is 625. This is a list that you really should memorize. It will make things much, much easier. Okay? So the reason that this will be helpful is that if I look at something like the square root of 8, you should recognize that the square root of 8 is not a perfect square. Nothing times itself equals 8. So what we're going to do is work on simplifying this, which means to break this thing down. And if you notice, you should know a couple of things about the number 8. In particular, if you look at this list, these are all perfect squares. And I noticed that 4 goes into 8, and 4 is a perfect square. So what we can actually do is we can rewrite this as the square root of 4 times 2. Well, the reason that that's helpful is because this can actually be thought of as the square root of 4 times the square root of 2. And the reason that's helpful is because we know that the square root of 4 is 2. So the square root of 8 is actually equal to 2 times the square root of 2. And if you were to go to your calculator and type that in, you will get equivalent answers for them. This is what simplifying irrational square roots means. It means to break out any perfect square that's actually in there. And what we really want to do is find the largest perfect square. Okay? So this is number 1. So if we were to look at something like the square root of 12, okay, think of the numbers that multiply to 12. Yes, 6 and 2 multiply to 12, but really in particular, we want to find the largest perfect square that goes into 12. And the largest one would be 4. So this is going to be the square root of 4 times 3, which can be written as the square root of 4 times the square root of 3. Again, we know the square root of 4 really is 2, so this would be equal to 2 times the square root of 3. Which again, you should always prove that this is correct. Go to your calculator, type in the square root of 12, then type in 2 times the square root of 3, and you should get the same answers. Okay? We have to be careful sometimes. So if we look at the square root of 24, okay, there are quite a few things that multiply to 24. Again, let's find the biggest number that goes into 24 that's on this list of perfect squares. Once again, we're looking at 4, so this would be the square root of 4 times 6. It is just a little strategy for me that I always put my perfect square first. So this is the square root of 4 times the square root of 6. Square root of 4 is 2. And something that's nice to know is that the square root of 6, that doesn't break down any further. There are no other perfect squares other than 1 that goes into 6. So the square root of 24 is equal to 2 times the square root of 6. Okay? I've already done 3 examples where these things break into 4 times something. Don't think that that's the way it will always go. So if I look here, I have the square root of 27. Okay, what's the biggest one of these numbers that goes into 27? That, of course, would be 9. So the square root of 27 is equal to the square root of 9 times 3, which can be thought of as the square root of 9 times the square root of 3, which is 3 times the square root of 3, because the square root of 9 is 3. Okay? All right. What about the square root of 98? Okay? So now, we might not know our factors of 98 by heart. So what you might have to do is just start dividing things. All right? So 1, of course, goes into 98. 4? Well, 4 doesn't go into 98 evenly when I check it on my calculator. 9 doesn't either. Let's see. Neither is 16 or 25. 36. 49 does. 98 is the square root of 49 times 2. Okay? So that's the square root of 49 times the square root of 2, which gives me 7 times the square root of 2. Okay? I look at something like the square root of 150. Now, it might come to mind quickly that 15 times 10 is 150, but there's a very important fact there. When I'm breaking these things down, I need to look for a perfect square that goes into 150. And the biggest perfect square that goes into 150 is actually 25. So this is 25 times 6, which I would write as the square root of 25 times the square root of 6, which means that square root of 150 is equal to 5 times the square root of 6. Okay? Something to be really careful about is the square root of 32. This happens all the time, and it's something to watch out for. Hopefully, we all know that 32 is 8 times 4. Okay? But the thing is, I want to make sure that I find the largest perfect square that goes into 32. 4 does go into it, but if you keep going and try other things on that list, you should also recognize that 32 is 16 times 2. So I would write this as the square root of 16 times the square root of 2, which is equal to 4 times the square root of 2. Okay? This is basically what it means to simplify irrational square roots. We are breaking out the perfect square. Okay? Now, we also sometimes have to put operations on this. So if I was to do something like 4 times the square root of 18, okay? The square root of 18 is an irrational square root. So what I'm going to do is break apart the square root of 18, and I'm going to kind of hold this 4 on the outside for a little bit. So if I break apart the square root of 18, that would be the square root of 9 times 2, which is the square root of 9 times the square root of 2. Square root of 9 is, of course, 3. So this equals 3 times the square root of 2. But let's not forget that 4 that was out there in the beginning. What this originally says is 4 times the square root of 18. I broke down the square root of 18 to be 3 times the square root of 2. I've still got to multiply that by 4. So what I do is I consider these as coefficients. So this would be equal to 12 times the square root of 2. And again, you should verify that by checking in your calculator. Okay? This was number 8. So then we go to 9, which would be, well, let's do 1/2 times the square root of, I don't know, let's say 12. Okay? So again, I'm going to hold the 1/2 for a minute. The square root of 12 is really the square root of 4 times 3, which is going to be the square root of 4 times the square root of 3. Square root of 4 is really 2 square roots of 3. So now I'm going to take that 1/2, multiply it by the 2. Half of 2 is 1, so this just equals the square root of 3. Once again, you should verify that. Okay? A couple other things to think about. So, along the lines of doing irrational square roots, what if I were to have something like the square root of 20 over 25? Okay, well, based on the work that we did in class on Tuesday, you know that we can just simplify the fraction. Okay? But the thing is, I recognize that this is going to be the square root of 20 over the square root of 25. The square root of 25 is easy. That's just 5. But what about the square root of 20? Well, that has to break down. What goes into 20? Okay, the square root of 20 is equal to the square root of 4 times 5. So that's the square root of 4 times the square root of 5. So square root of 20 is 2 times the square root of 5. What you have to be very careful about is asking yourself if this simplifies any farther. These things right here, the square root of 5 really is under the square root, so you cannot divide these things out. This is in final form. Okay? Now that's a little bit different than if I were to do the square root of 20 over 4. The square root of 20 over 4 would be the square root of 20 over the square root of 4. Thank you. So we know the square root of 20 from what we just did is 2 times the square root of 5, and we know the square root of 4 is just 2. Notice the 2 was on the outside of the square root, so now these can actually simplify. 2 divided by 2 is 1, so this thing just ends up being the square root of 5. Okay? All right. We can do it with variables too, and this will be just about where we end. So keep in mind that the square root of x to the 6th is equal to x to the 3rd. X to the 6th is a perfect square. Well, what about the square root? Well, let's not make that number 12. What about the square root of x to the 7th? Okay, I want to think about breaking that apart just the way that I did these other ones. The biggest perfect square that goes into x to the 7th would actually be x to the 6th. This can be written as x to the 6th times x. Okay, remember there's really a 1 right there. Well, 6, so our product rule. So this is really equal to the square root of x to the 6th times the square root of x. We know that the square root of x to the 6th is x to the 3rd. So here is what we would get in simplified form for that. Okay? So, for class tomorrow, I would like you to please try a couple of these. How about we do... let's just do a couple of ones with variables. So we'll do the square root of y to the 9th, see if you can apply the idea here. And let's try the square root of 4 d to the 6th e to the 7th. What do you think about those two examples? If you have any questions, please have them ready for class. I will also be here early in the morning. See you later.